Hello, hello, hello. This lesson here, Similarity 5. Oh, that's where I should start. 5.1, Properties of Geometrical Figures. It's past paper time. This topic, not that much in it, so we can go to past papers. And we've got a selection here. So some are from 2020, some from 2019, some 2018. Bit of a mix. But we start off with the full 2020 paper. I'm not, you're not watching me do it. If you're in class, you'll have the whiteboards. Do the question, then I show you the answer. Do the question, then I show you the answer. If you're at home, same thing. Have a go at the questions. I might make them available in OneNote for you. No, they're always in the content library. Just go to the content library, and I'll just make it so you can see for a bit. And bye-bye. Hello. Oh, you can't see it? Oh, you can't see it. Anyway, mucking around too much. What you'd have is you just go to the content library and then select it and you right click on it and you copy it, and then you can copy and then on your own version of it, then you'll be able to do it. Hey, enough talk. So have a go at the first question. I'm going to have a go give the answer in 5, 4, 3, 2, 1. Two figures are similar. Let's keep it simple. Same shape, different size. That's good enough. Same shape, different size. You want to be more precise? You'd say all angles equal, or matching angles equal. And matching sides in the same ratio. That is a precise definition. Hey, but either's fine. Either's fine. You say that, tick, or you do that, tick, either one. Good. So have a go at question 2. And answers in 5, 4, 3, 2, 1. So, what's the side? Name of the side corresponding to AC. So AC is the shortest one. So it corresponds to that one. Now, is it GE or is it EG? Which one is it? It's only one of those two. Now, it has to be in the right order. A was this big obtuse angle there. Did you get that? So it's not GE. It's EG is your answer there. Got to be EG. So give yourself a tick if you're at EG and a cross if you're at anything else. Scrolling down. 3, 2, 1. Number 3. Have a go at it. I'm going to do it in 5, 4, 3, 2, 1. So, scale factor of 3. They gave you the scale factor. And that and 5. Wow. What an easy question. X is 15. Wow. Moving on. 3, 2. You just need to know what scale factor meant. All right. This one will take a bit of time. List all matching sides and angles. Have a go. Answer in 5, 4. So, if you want to be precise with your angles, you'd say like angle F, IFG, or something like that. But I'm going to be lazy and say angle F, angle G, angle H, angle I. What are those equal to? Well, F is R, G, down the bottom S. So it's a mirror image with a slight rotation. F, R. G, go down to the corner, another 90-degree angle, etc., etc. And then I. But then you have to do the same thing with the sides. So I'll do it in order. FG, GH, HI, IF. And I can go that F is equal to R, S. So RS, SP, PQ, QR. So I was just using what we got on the sides there. I wasn't even looking at the diagram. If we go in order, it's RSPQ. So RS, SP, PQ. Yeah. But you can double check it. FG, RS, GH, SP, HI, PQ. Done. That's a C. Scrolling down. I keep doing that off camera. ABC. It's because this is in my way today. It's my microphone. Whoop. ABC has been enlarged. Oh, you're going to need a ruler. I got a ruler, but I don't have it printed here, so you're going to do it on your paper and find out what it is. I'm going to guess that's like 2.5 centimeters? Question mark. And maybe that's 7.5 centimeters. So the scale factor would be 3? Question mark. I didn't give you time to do it. Oops. Just gave you the answer. I could edit the video, but I won't. Scrolling down. 3, 2, 1. Da-da-da. 2 triangles below are similar. Find the scale factor and then use it to calculate the values of x and y. This time, you have a go. Then I give you the answers. Answers in. Alrighty. So, find the scale factor. They're really nice. Normally, they'll just tell you calculate the value of x and y. That's all they'll tell you to do. But here, they were nice. They said, hey, hint, find the scale factor. So we need some matching sides for this. 5 and the 10 times by 2. So therefore, 4 to that times by 2. But now going the other way, divide by 2. Now that's all real rough. But, so it's a B, so we got to prove it. So the scale factor, if we want a B, we've got to earn it. Can't just say what, y is 8 and x is 7. Not good enough. Scale factor is the image over the original. It's the new one over the old one. That's all it means. And I've said the one on the right is the new one. So 10 over 5, 2. Next, so what we can say is the y is 4 times 2, which is 8. And the x is the 14 divided by 2 equals 7. Done. That's worthy of actually getting the correct mark. So, scrolling down. 3, 2, 1. But still, easy B-level question. All right. Ooh, distance between Peel High School and the Golden Guitar. Ruler. And we need a scale. Now, this is where it gets tricky. So, I pretend this line is straight. It's not, but pretend it is. And also pretend it's 12 centimeters. Crap, we should be having a go at this. So have a go. Ta-da! So pretend that. The tricky bit is the map scale. That looks to me like 1 centimeter is 500 meters, I'm going to assume. So therefore, you take your 12 centimeters times by 500, 6,000. So therefore, the distance would be 6,000 meters. Well, there are different ways to set it out. You could set it out like this. The 1 centimeter is equal to ratio 1 centimeter will give you 500 meters. So if you times by 12, times by 12, and you get, I have to check, 500 times 12? Yeah, times by 10, 5,000. Yeah, it's correct. Cool. So the distance, 6,000. Wow, that's it. It's going down. All right, A-level question. And then we're on a different test. So have a go at this one. 5, 4, 3, 2, 1. Okay, here we go. My turn. Allison, trip to Sydney. Wonders how tall Sydney Tower is. Yeah, it's this type of problem. We've seen it before, right? Once you've done enough questions, You know what they're going to say. You read just to make sure. She's sitting in a cafe, 500 meters, there to there. That's 500. Notice water bottle lines up with the tower perfectly. Perfectly. 42 centimeters. The water bottle was 26 high. Household city tower. What they big problem here is they don't give her height, Alison's height, because that is also part of it. That because that is a horizontal line there. So her eye, if she's down here, then the rest of her head and body, yeah, that is not a good body, etc. Yeah. I'm gonna get rid of that. But yeah. So they've left that out, but their fault. How tall is Sydney Tower? Diagram not to scale. They do that so you can't just use a ruler and figure it out. Redraw it. You've got two triangles. 42 centimeters, 26 centimeters. Now this is A level, so the units are a bit weird. It's 500 meters, which is 50,000 centimeters. Or you could change that to 0.42 meters. I'm going to put everything in centimeters. So we got 50,000. And we're going to get some height in centimeters. And we'll have to get it back to meters when we're done. So similar triangles. The scale factor. Going from here to here. The new one. Of the old one. Ooh, I don't know what that is. 125 roughly. Well, that's just crap. 100,000. No, 1,200. It was off by a factor of 0. Factor of 10. This is me being sleepy. It's past midnight. Ooh, 4, 7, 619. So you get fancy scale factor. So the height is the 26 centimeters times it by that. So take that times by 26. We get 30952.38095 centimeters. Meters divided by 100. 309.52. Yeah, it's 5 to 38095. Meters, nearest meters, 310. And I think that's our test. All right, but we're going to keep going. We're not done yet. Got some other questions here, starting with sea level ones from a previous test. So have a go at this. Answers in 5, 4. So this is what I talked about before. They just say calculate the value of x. Now this one I like because it's tricky. So we've got the circle, matches up with the circle square, and I'm going to put a asterisk there, and that lines up with that. All right, so we've got to find which sides match up with each other. So we've got the 12. And that, look at what's opposite. Opposite the square. So what's opposite the square? 16. So now we know that those two match up. And what matches up with the x? Well, the x is opposite the asterisk. So those match up too. Good. So let's do scale factor first. And then going from that one to that one. Scale factor of that one was our 16 over 12, 4/3. So x is take the 18 times it by 4/3, 24. I don't know where they got centimeters or not. Yes, they do. Centimeters. Done. Scrolling down. This one. Have a go at this one. Enlarge the shape. Answer in 5, 4, 3. Enlarge the shape. So that's, don't need a rule, well, you need a ruler to draw straight lines, but that's 4 units here. I don't care if it's centimeters or not, but it's 4 units on the grid. That's 4. That's 6. And once I've got those 3 sides, I'll just join them up. So if I start from here, scale factor, 4 times 1.5 equal to 6. 6 times 1.5 equal to 9. Because it's 1 lot of 6 plus half of 6 is 3. 6 plus 3, 9. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then this one, that's our 6, but we need another 3. And then we join them up. Done. Use a ruler. I can't get full marks without a ruler. Scrolling a little bit down. So, scale used on a map. Now this, ratio questions, this is year 8 stuff, but probably a lot of people have forgotten about it. Is 1 centimeter gives you 1 kilometer. That's what it means there. That's 1 centimeter. We can simplify that. Kilometer is how many meters? 1,000. How many centimeters is that? It's 100,000. So our ratio is 1 to 100,000. Oh, what is a measured distance of 5 centimeter represent on the map? Well, 1 centimeter is 1 kilometer. So 5 centimeters is 5 kilometers. Wow. Part B was easier than part A. I know that's year 8 because I just taught it. Scrolling down. All right, have a go at this one. It might have been copied directly from a book. You might have done it already. Answering. Okie dokie. Now, the building is 36 meters from the post. I just look at the diagram and I go straight away. That's 36. Not the whole thing. Redraw the 2 triangles. Everything's in meters. 9, 4.2 meters. Big one. 36 plus 9 is 45. So now, scale factor. Going from that to that. 45 over 9 is times it by 5. H equals 4.2 times by 5, 21 meters. Done. Scrolling down. A-level question. Draw a bedroom. So how do you do this? Have a go. Okay. So 1 to 50. So first thing, what that means is 1 is the original. 2 is the new. It's the image. It's the new thing. So we have to times everything by 50. Everything is 50 times bigger. Wait. But we are, my fault, going from the image to the original here. So what that means, if you start off with the image and you want to find out how big the drawing should be, you're going to have to divide everything by 50. So the room is 800. Put everything in centimeters to start. 800 by 600 centimeters. The bed, 200 by 150. The desk, 260 by 120. The cabinet, 200 by 80. And the bedside table. 40 by 20. So those are the real measurements, So now what we need to do is divide everything by 50 to find out the drawing. So divide that by 15. What you do is divide by 50 is double it and take off 2 zeros. Because it's like times by 2 dividing by 100. So double it, take off 2 zeros. Double it, take off 2 zeros. Double it. 520, so 5.2. Double it, 24, 240, 2.4. Double it, 404. Double it, take off 2. Or, of course, you can use a calculator. Slower, but works. 800 divided by 50. Yeah? Also, you can be more confident that you got it right the first time. My fault. Divided by 50 equals 12. So now we've got the measurements. The room itself. So 16 by 12. So over here in your book, 12, and use a ruler, of course, and measure it. 12, 16, and then put them where you like. The only thing is, nothing should overlap, so no bedside table on top of beds. There's no door, there's no windows, just dump them anywhere you like. So bed, desk, cabinet, bedside table. The bed, throw in a corner. 4 by 3. Get it right though. I'm being really rough here. Bedside table. You can put it wherever you like. Might as well put it over here. Oh wait, I even skipped it. That's so bad of me. Bedside table. 4, 8. That's 0.8 centimeters. I'm 0.4 centimeters. My bad. I'm going to put my bedside table over here. With I made it too rectangular though. You get the idea, right? You get the idea. 0.8, 0.4. As long as everything is to scale, you'll all be good. Desk, etc. Just dump it anyway. It doesn't matter where you put it. You put the desk in the middle of the room. Why? Because I felt like it. That's why. Desk. Wait a minute. That desk is enormous. Maybe they did that on purpose. A 2-point. That's not a desk. That's a table. 5.2 centimeters by 2.4 centimeters. And missing a cabinet, 4 centimeters by 1.6. What you should do is write what they are. Definitely. Write your bed, write your desk. I'm putting my bedside table over here. And that is our cabinet. All right. So this is really an exercise in converting to centimeters, getting the actual measurements. Drawing wasn't very tough. Scrolling down. Last question. House plan, 200. 1 to 200. Answer the below questions in meters. Have a go. Answers. 1 centimeter. Whoa. 1 to 200. So what that means is if you have 1 centimeter, you can have 200 centimeters. But it says to answer in meters, so 2 meters. Real exterior length, all right. Measure that with a ruler. Let's just say it's 11 centimeters. Probably more than that. So 11 centimeters times it by 200. 22 and 2 zeros after it. It should be 2.2. That doesn't all right. 22 meters. was going to say 2.2 meters, and it's like, that ain't right. Looking at the great window, what's the real length of the window? Great room's in the middle there. What is the real length of the window? I don't know, that's 1 centimeter. So it's actually 200 centimeters, which is 2 meters. I should say times 200. Now, but measure it properly. What if it's like, let's pretend it's 0.7. Then times it, get 140, and get it right, because those decimals matter. So when you're measuring something that's small, be precise. Definitely nearest millimeter. All right, hey, that's all these questions. Oh, no, it isn't. Look at that. I'm just scrolling to be safe. Real lengths of the bathroom. There we go. This is more like it. I'm thinking the question's a bit easy. Bathroom is tiny. Say it's 1 centimeter. And let's call it 1.4. So dimensions. We don't want the area. We don't actually care. We don't care about that. So it's 2 meters and then 1.4 we said. 28. So right, the dimensions are 2 meter by 2.8 meters. Yes, and I should have made it clear. That was my answer though. Real length of the window, or maybe it's that. One of the two. Who knows? Done. Video's over. Bye-bye.